Welcome. Today we'll prove that the derivative of secant of x is equal to secant of x times tangent of x. Let's start by writing out what we want to prove. First, let's recall that secant is defined as 1 over cosine. We can write this as a fraction. To find the derivative of this fraction, we'll need to use the quotient rule. Remember, the quotient rule states that the derivative of u over v equals v times the derivative of u minus u times the derivative of v all over v squared. In our case, u equals 1 and v equals cosine of x. Let's identify these parts. U equals 1, so the derivative of u is 0, and v equals cosine of x, so the derivative of v is negative sine of x. Now, let's substitute these into the quotient rule. We get cosine of x times 0 minus 1 times negative sine of x all over cosine squared of x. Let's simplify this expression. The first term becomes 0, and the negative of a negative becomes positive, giving us sine of x over cosine squared of x. Now, here's where we use some trigonometric identities. Remember that secant of x equals 1 over cosine of x, and tangent of x equals sine of x over cosine of x. Looking at our current expression, we can rewrite it as secant of x times sine of x over cosine of x. And since sine over cosine is tangent, we get secant of x times tangent of x. And there we have it. We've proven that the derivative of secant of x equals secant of x times tangent of x. This proof used the quotient rule and basic trigonometric identities to arrive at our result.